Okay, so this is the first derivative test. I'm assuming that you have seen this and this. These are super important. I've seen this in previous videos. I assume you have seen this slide and that it is in your notes somewhere that's very important. And I assume that you have grappled with these questions, that you have worked on the questions in the worksheet that's been posted in Canvas before you've even sat down to click on this video. If you haven't, just hit the pause button, go download the sheet, try the questions. I will work through the questions from the front side of the sheet in this video. Again, for us, the goal is to look at intervals of increase or decrease, local maxima or minima for these functions. Every time we're looking for intervals of increase or decrease, we're interested in where f prime is positive or negative. So f prime in this case, we're looking to see where f prime is positive or negative. So I'd love to be able to set up some number line for f prime so I know where the positives and the negatives are. But it'd be nice if we could factor this. So we'll pull out a 4x and then that difference of 2 squares. So there are 3 places where f prime is 0. F prime is 0 at -2 and 2 and 0, and we mark those on the number line. So this is a cubic function. It's got a positive lead coefficient, so f prime is a cubic. It does one of these. So it starts low, it ends high, starts low, it ends high, and in the middle it changes sign twice. Or you can take your calculator and graph this thing and figure it out below the axis, above the axis, below the axis, above the axis when you graph this in your calculator. So here's the important thing for the first derivative test. If f prime goes negative, positive, negative, positive, then f goes decreasing, increasing, decreasing, increasing. And that means that f has a local max at x equals 0. Why? F changes from increasing to decreasing, increasing to decreasing. That's a max. We don't write information about f, we write information about f prime. F prime changes from positive to negative. Similarly, we write that f has a local min at x equals -2 and x equals 2 because f changes from decreasing to increasing, decreasing to increasing, decreasing to increasing. So that's a min, that's a min, but we don't write about f, we write about f prime. F prime changes from negative to positive. This will always be the reason for a max off the first derivative test, and this will always be the reason for a min off the first derivative test. So this is the most basic sort of question you can be asked about intervals of increase or decrease, local maxes, local mins. Number 2, again, I'd love to be able to set up some kind of chart for G prime. There's already one place that's going to give us trouble because the function is undefined at 2. There's an asymptote at x equals 2. So let's try to take a look at what G prime is doing. I hope you know what I'm doing here. If you don't, I don't know what to tell you. Right? So a little bit of algebra, and I can do this because if I'm really going too fast on this one, you can hit the pause button to figure out how this became that. It's different to record a video than it is to do things in class. I would give you lots of time to process algebra in class, but you can always hit a pause button and then we can save the universe. So this is our g prime. G prime is only 0 in two places, at x equals 1 and x equals 3. And then what? Well, then we try to figure out what's happening in between those values. So we plug in our favorite value that's less than 1, and we figure out what's happening here. Turns out you get a positive answer. You take your favorite number between 1 and 2, you plug it in. Turns out you get a negative answer. You take your favorite number between 2 and 3, you plug it in. Turns out you get a negative answer. You take your favorite number that's bigger than 3, you plug it in here. Turns out you get a positive answer. So what does this mean? G prime goes from positive to negative, negative to positive, because G goes from increasing to decreasing, decreasing to increasing. What does that mean? So G goes from increasing to decreasing. This is a max. G goes from decreasing to increasing. This is a min. How do we write that? G has a local max at x equals 1 because G prime changes from positive to negative. G has a local min at x equals 3 because G prime changes from negative to positive. This will always be the reason for a max when we're using the first derivative test. This will always be the reason for a min when we're using the first derivative test. One more to consider of this type. Again, I'd love to set up a number line. Here, we're only concerned with x's that are greater than or equal to 1, because if x is less than 1, this is x minus 1 is negative, and if x minus 1 is negative, then we don't have a square root. So we're only interested in x values that are greater than or equal to 1. H prime derivative of x is 1. Derivative of a square root is 1/2 times the thing to the negative 1/2 times the derivative of the inside, but that's 1. So what is this? 6 times 1/2 is 3. This to a negative 1/2 looks like that. And we're going to try to see where this is 0. Well, you can try to figure out where this is 0. Kick that over to the other side. Looks like x is 10. That's an existential problem. Never mind, I'm all done. Okay, anyway. So you pick your favorite number between 1 and 10, you plug it in here, you get a negative answer. You take your favorite number bigger than 10, you plug it in here, you get a positive answer. What does that mean? That means h prime goes from negative to positive. If h prime goes from negative to positive, x equals 10 is the min. H has a local min at x equals 10 because h prime changes from negative to positive. H is decreasing here and increasing there. That's what the first derivative test does for us. Question 4 asks us to find an A and a B. So we know that this point is on that curve, so we can substitute 1 for x. We can substitute 1 for x, and that's the y value that comes out. But we know that it's got a maximum at that point. Well, at a maximum, the derivative is 0, if there is a derivative at all. And so what's the derivative here? The derivative is 2ax plus b. And what's the x value? Right? So now you got this equation and this equation, and that takes you back to Algebra 1, where you had, Juan and Maria go shopping. Juan buys an apple and a banana for $2. This doesn't really make sense in that context, but we solve this system. And if we solve this system using the tools of high school, A is -2 and B is 4. Okay, those are the things I need to make sure that you know how to do. There are questions on the back side also. I'll post the answers without comment or commentary. They will make a little more sense after the next lesson, but I'll post those without comments or commentary. Hopefully this is helpful. We march on toward the second derivative for next time we're together.